So suppose that your professor is in a sinister mood and they give you this problem. Simplify the cube root of x to the power 121, y to the power 152. Now, the exponents here are so incredibly large that there is absolutely no way that I would solve this by grouping, because I just don't have the time to write down 121 factors of x and 152 factors of y. So we're going to come up with an alternate method, which I will call dividing exponents, to help us when the exponents are really large like this, and it's tedious and not efficient in terms of time to write down and group the factors. So here's the principle. I am going to do a long division. I'm going to do a long division in two different cases, one for each base. I'm going to do a long division, and I'm going to do the exponent that I'm starting with. Let's say starting exponent. So my starting exponent for base x, in our case, is 121. And the starting exponent for base y is 152. What I'm going to do is I'm going to divide that exponent into groups of 3. I'm going to divide that exponent by the index of 3. Now, if you do this on your calculator, you'll find that both of these turn out to be decimal numbers. And when we're working with exponents, we try to avoid decimals when we can. So instead of doing that, I'm going to go all the way back to the beginning of my math career, before I even knew what a decimal number was about, back when division meant quotient and remainder. So how many times does 3 go into 120? 3 can go into 120 40 times in full. But if 3 goes into 40 times, 3 times 40, that's only 120 so far, which means that there is one more x left over. So what is happening here? If I did go through and write down 121 copies of x, I would be finding 40 groups of 3 in that list, 40 groups of 3. And then there would be one x remaining, one x left over inside the root. So this is the number of groups, and this is going to become the exponent on the outside of the root after we simplify. And this last quantity here in blue, this is the number of leftover x's, and this will become the exponent inside the root. And I'll show you what I mean soon. Just for consistency's sake, let me make this 40 green. All right, now moving on to base y, 3 goes into 152 50 times in total. Now 3 times 50, that's only 150 so far, so I would have 2 left over. What this means is, if I wrote down 152 copies of y, I would find in that list 50 groups of 3. And then there would be 2 y's left over who couldn't be paired into, or I should say grouped into, a group of 3. So what I can do now is I can take these exponents here, these numbers that came from the quotient, and I can say there were 40 groups of 3x's. So 40 x's will make it outside the root. There were 50 groups of 3y's. So 50 y's made it outside the group. So 40 is the exponent of x on the outside. 50 is the exponent of y on the outside. Now, inside the cube root, who is left behind? Who's left behind? There is one x left behind on the inside. One x. And there will be two y's left behind on the inside. 40x, 50 for the exponent of y, cube root x times y squared. That is how I would simplify a question of this complexity.